This video assumes you've installed the Modbus TCP COM module, it has up-to-date firmware, and you're familiar with how to configure it for Modbus TCP. Check out these videos if you need help with any of those. Our goal in this video is to control a SureServo 2 drive from a PLC via Modbus TCP. I'll be using an Automation Direct Do More Bricks PLC for this example. We'll set up our network addressing like this. I'm choosing these addresses because it uses the SureServo 2 drive's default addressing, which means we won't have to change any of that. If you're using the drive on an existing network, you'll need to change those numbers to work with that network. Again, see this video to learn how to set up the TCP COM module to do that. Let's go to parameter 3.064 and set it to a 1 to reset the TCP module's IP addressing to those default values. That automatically copies the module's networking configuration to these drive parameters so we can see them. This is the one time you don't have to power cycle the drive to get those transferred from the TCP module to the drive. Well, now we need to get the Do More PLC on the same subnet and start talking to the drive. But before we do that, there's one key concept you need to understand before using comms to talk to a drive. When you enter a parameter via the drive's keypad or via the free SureServo 2 Pro software, most parameters get written to non-volatile memory, so next time you start the drive, they'll still be there. The problem is, non-volatile memory has a limited number of write cycles before it fails. That's typically millions of writes, which means it's almost impossible to use up the non-volatile memory from the drive's keypad or the SureServo 2 Pro software. With comms, it's a different story, because you could write a PLC program that hammers the drive with lots of parameter changes every second, which means if you aren't careful, you could easily use up the non-volatile memory very quickly when using comms to change parameters. So it's a really good idea to set parameter 2.030 to a 5. That tells the drive not to store any Modbus commands in non-volatile memory. Of course, that also means anything written via Modbus won't be retentive. If you do want something to be retentive, just write a -5 to parameter 2.030 to turn this feature off. Write the retentive parameters, then turn the feature back on by writing a 5 to parameter 2.030. Okay, enough of that. I set up this drive in position register mode to rotate this disk back and forth. Watch this video to learn how to do that. In that video, we triggered the path from the free SureServo 2 Pro software by entering the starting path here. And all that did was enter the path number in parameter 5.007. We could also enable or disable the servo by clicking here, which simply wrote a 1 or a -1 to parameter 2.030. Let's set up the Do More PLC to do all of that. That is, let's have the PLC set parameter 2.030 to a 5 to disable retentive writes, a 1 to enable the servo, a -1 to disable the servo, and write a 1 to parameter 5.007 to trigger path 1. Now keep in mind that if you're also controlling the servo enable via a digital input, then enabling the servo is an OR function. The servo will be enabled if either the digital input or the parameter enables the servo, which also means both have to be disabled to disable the servo. And we should do a read, so let's read the drive's firmware version in parameter 0.0. To set up the Do More's networking, just go to the dashboard and click on the Ethernet port and change the IP configuration. I've already entered an IP address for this guy to be compatible with the drive's default addressing. On our first rung, we'll read the drive's firmware version when C0 goes active. We need to do a Modbus read using the Bricks PLC's built-in Modbus TCP client, which is set up and ready to use out of the box. We want to talk to the drive at its default address of 192.168.1.10. This needs to be whatever the drive's ID is in parameter 3.0. We haven't changed it, so I know it's the default 127. We want to read a holding register. Which one do we want to read? We want to read the firmware version in parameter 0.0, so we go look in the manual, and in the parameter definition, it tells us the Modbus offset is 0 and 1 for each of the two 16-bit registers. So we add a 0 offset to the base address, which is 1, and put that here. Now I should point out that while the Do More starts its Modbus addressing at 1, some PLCs start at 0. So add the register address to whatever your PLC's base address is. And we want to read both of those 16-bit registers. By the way, every parameter in a SureServo 2 drive is two 16-bit words or two Modbus holding registers wide. I love that because I don't have to remember which parameters are 1 word wide and which parameters are 2 words wide and have to modify my code accordingly. Having every parameter use 2 words massively simplifies your programming. And we'll put the result in a single double-wide register D0. Could you put it in 2 single words starting at, say, N0? Sure. And for some instructions, you may want to do that. We'll put this in a double word. We'll run this instruction only once on the leading edge of the contact, and I'll add some error bits and an exception response register. That'll give us an error code that will help us debug things if something doesn't work. You can add an end if you want to. The DoMore doesn't require it. Accept the changes and send it to the PLC. I'm assuming you know how to do that. I created a data view and named everything to make it easier to read. The PLC is connected and running, so I'll just toggle this contact, and sure enough, we get the expected firmware version. Perfect. Okay, that was reading a register. Let's write some registers so we can control the drive. Again, it's good practice to set drive parameter 2.030 to a 5 so you don't use up the non-volatile memory. Now, we don't really need that for our little demo, but let's do it anyway just to see how it would be done if you did need it. Let's use C1 to trigger that, and we want to do a Modbus write to the built-in TCP client to the drive at address 192.168.1.10. Again, you'll use your drive's IP address here. The port number's fine, and the drive's default ID is 127. Again, that's in parameter 3.0. We want to write to parameter 2.030, which the manual tells me is offset by decimal 572. So we add that to this base address and put it here. And remember, while the DoMore starts Modbus addressing at 1, your PLC may start at 0. Again, all SureServo 2 parameters are 2 words wide, and we want to write a 5 to disable the non-volatile memory writes. We're only running one instruction at a time, so I'll use the same status bits as general purpose status bits. Normally you would use separate status bits for each instruction. Enabling the servo uses the same parameter 2.030, so I'm just going to copy that whole rung, put it here, modify the comment, and we'll use a different C bit to trigger this. The only thing that changes is we want to write a 1 to enable the servo. And I'll use our general purpose status bits again. Disabling the servo is identical, so I'll copy that rung, paste it here, change the comment, trigger it with a different C bit, and send a -1 to disable the servo. Finally, we want to trigger the position register mode path I set up in the drive by writing to parameter 5.007. That's very similar to what we just did, so I'll copy that rung, paste it here, change the comment, and use a different C bit to trigger that. This time, we want to write to parameter 5.007, which the manual tells me is at an offset of 1294 decimal, so we just add that to the base address and put it here. We want to start at path 1, and again I'm going to reuse the same status bits. Accept all that and write it to the PLC. I gave all the C bits and registers names and created a data view so we can see what's going on. Let's disable the non-volatile memory writes by toggling this. We don't really need that for our little demo, we're just doing it as a reminder. If I reach over and rotate the servo motor, I see it's not currently enabled. So let's toggle this to enable it, and sure enough, I can feel it's now enabled. Let's trigger the position register mode path I set up in a drive. Yep, the path is now running. And let's toggle this to disable the servo. Perfect. Well, that ought to be enough to get you started with Modbus TCP communications with the SureServo 2 system. Click here to learn more about SureServo 2 and to find more of these tutorial videos. Click here to be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.